Hi, I'm Mansi More. I'm an AI engineer. I live in San Francisco. I build AI tools on new AI platforms and usually for the kind of real life stuff that's not so glamorous but like bit messy but actually useful. For example, a DIY food recipe generator. And this time also I built something like this. So couple of days ago my kitchen sink faucet started leaking. I was like already running late, no time to Google or like call a plumber. And I thought, okay, dude, I built AI tools, and this is exactly the kind of problem I should solve with AI. So I started building. The idea was simple. What if I had a smart assistant that could read repair guides, look at broken stuff, and just tell me how to fix it? No hunting through manuals, no YouTube videos, just answers. And that's what this project is about. It's DIY home repair helper. Okay, now again, here's the problem. The data is like super messy. It's in unstructured format like .pdf, .txt, image, video, and a very long process like starting from this fetching data set, cleaning it, embedding it, and like storing it in a vector database. And why not to do all things together? That's when Aparavi comes in a picture. Aparavi is a data management tool which helps me clean, classify, give like structure data, and it's like useful for AI. So then I use Quadrant to store vector embeddings and LLM to answer questions in real, like natural language. And it works literally for everything text, images, like videos, and gives step by step repair advice right when you need it. So it's a multimodal enterprise RAG using Aparavi and Quadrant database. Let me show you how it works.
Alright, so here is the actual pipeline I built using Aparavi data toolchain. Let me walk you through it. It's like a smart assembly line for home repair help, and it's not at all technical. Let me break them down. We start with AWS S3. So this is where I store all my repair data, PDF, images, or maybe even video clips. If you go on settings, you can see I've provided access key and secret key of AWS S3 bucket and the included path. So you don't have to do anything, you just have to go to AWS S3 bucket. So this is the data, this is the bucket I have in my S3. This is the data set, or the folder I would say, of the data set. Parser splits everything by type. Like see, this is the data and it is split by like audio, image, table, text, video, and so each can be handled properly. So here we have the text and table preprocessor. So text and tables are go through a preprocessor to clean them up. Cleaning means like removing noise, formatting stuff, making just to make it ready for AI. We have also image thumbnail here. So images get converted into thumbnails so that it can be useful for fast visual reference or metadata tagging. I've used audio transcribe also. If there is a audio or video input, Aparavi will transcribe it, turning speech into text that we can search or embed. So I also took question generator here. So there's also a question generator for text. It helps train the system to anticipate what users might ask. And here I've used this one kind of a transformer. Instead of this, you can use OpenAI image and transformer. Here I've used transformers, which converts clean content into vector embeddings, and it works across like all input type: images, text, audio, or even transcripts. So next is the vector store quadrant. Everything lands in quadrant, a vector database that helps find the most relevant content fast based on the similarity. Vector store is specifically for that vector, which means finding a similarity search. So when someone asks a question, the Gemini LLM uses that vector data to craft a smart contextual answer. And at last we have HTTP result. So finally the answer, whether it includes text, images, or instruction, it's sent to front end via this HTTP block. So this is my full data flow from like raw files to clean structured answers you can actually use to fix stuff around your house. It's like modular, scalable, and honestly it's like really super satisfying to build. Okay, so now let's look at this knowledge graph I built using Neo4j. Neo4j is a graph database which stores data as a network of interconnected nodes and relationships, and we can use it to identify patterns or maybe like transversing data relationships and building recommendation engines. Let me show you actual use of it. Let's say I have one problem and I want to set what repairs can I finish in under 30 minutes using what tools which I already have. So here is the way. So I selected projects as a node, has property as has estimated time, which is 30 minutes, which requires tool. So this is what I came up with. For example, we have like replace window screen, which has estimated time as 30 minutes and which required tool is flathead screwdriver. Let's take a second example. Install dimmer switch. So we have to like change light fixture and it can be done in 30 minutes. Seem like that we have like plenty of the nodes. It may look crowdy, but you can even change the nodes query limit. You can keep even 20, 10, whatever you want as per your requirement. Okay, let's dive into the code now. So this is my Aparavi challenge folder. We are having like RAG database, the dataset which we have here, and the images folder, the .env template file, and yes, this is the virtual environment. So we are creating virtual environment so that if we are installing any libraries, it will install on the virtual machine instead of installing it on our local system. So we have like this. So this is our chat.py, the main file, and yep. So let me just briefly explain you about this file. And we have like .env file which is like connected with this file, and yeah, obviously we have like all API keys. I'm not gonna open it because it's pretty much confidential. And we are like, this is OpenAPI configuration. Here we are testing OpenAPI connection, and the Qdrant configuration where we have Qdrant URL, Qdrant API key. The Qdrant connection testing will happen here. And yes, this is the system prompt. And before giving this prompt, you have to be like very specific, and you can write it in very short. Okay, so here I've written, you are a helpful AI assistant that answers questions based on the provided context, and if it is not relevant, it should see that the information is not relevant. These are the embeddings and the hybrid search function, which will perform the hybrid search across the multiple collections which we have in our Qdrant vector database. And again, this is the predicted hybrid search. And from here, Gradio user interface will start. Get collection. So basically what it does is, if we ask any question, it will fetch the collection from the Qdrant vector database, and it will show you the information. If the hybrid search is like matching with it, it will say so. Otherwise, it will reply with the text that I couldn't find any relevant information from the selected collections. And yeah, sending the OpenAI request, and it will show if it is like matching, then it will show it is received response from OpenAI. Here are CSS style dot, and this is the index.data where it will show about the collections and all the information we have in our database. And yes, this is the important file.txt, Gradio OpenAI Qdrant. So Qdrant is our Qdrant vector database, OpenAI API key which we use for our AI assistant to get accurate information, and Gradio is our user interface. If you are not familiar with Gradio, you can go with Streamlit, anything is fine. Let me just quickly run this code. Okay, as we can see here, as I mentioned in the chat.py file, it is showing that it is initializing OpenAI collection, testing OpenAPI connection, initializing and testing, and successfully connected to Qdrant connection. And these are the list of collections we have in our Qdrant. Let's see the chat interface. Here we go. So this is my DIY home repair AI assistant, which is nothing but multimodal RAG chat interface. And these are the list of collections we have in our Qdrant. This is the chatbot window, some tips for the user, and text box and send. Let me select Aparavi here. Aparavi is, so on Aparavi dashboard, if you remember, on vector dataset store, here we have selected collection. It is nothing but the collection which we're going to use on radio. Let me refresh the collection and ask the question like, hey, how do I repair a leaking faucet? I don't know why I asked the question in the start. Okay, so based on the information it is giving blah 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 blah. Let's move towards next question. And let me refresh it. Okay, here we go. You can see here on your terminal the question you have asked and its reply and the matching. So basically we are doing like semantic search, and it will show you the matching score of the search. Received response from OpenAI.